This week we'll talk about the Respiratory Protection Program. This PowerPoint was provided by Carlos Bejar, a great professor that I mentioned previously, that works in our Environmental Technology program here at Southwestern Community College. So let's begin. So when it comes to the Respiratory Protection Program, the relevant regulations fall under the California Code of Regulations, Title 8, Section 5144. This section contains a series of appendixes that contain procedures regarding how to perform the fit testing, the user seal check procedures for the respirator mask, the respirator cleaning procedures, the medical evaluation questionnaire that all employees that use a respirator need to fill out every year, and the information that for employees that use respirators when not required under the standard. That is, when employees want to use a respirator on a voluntary basis, what information do they need to know? Prior to us beginning, there's several OSHA definitions that we must know. First, we have TWA, which stands for time-weighted average. The time-weighted average, and I'm going to switch on the slides for a moment, is the average exposure for an individual over a given working period as determined by sampling at a given time during the period. Usually when we talk about the time-weighted average, we're referring to an 8-hour interval. That is the average concentration to which an employee was exposed during an 8-hour workday shift. And we can be talking about, for instance, the exposure to noise, which will be measured in decibels. We could be talking about exposure of the employee to an airborne substance, in which instance we will be referring to particles per million or milligrams per cubic meter. Now, the next abbreviation would be PEL, the permissible exposure limit. This is actually enforced by OSHA. This is the permissible concentration in air of a substance to which nearly all workers may be repeatedly exposed for 8 hours per day, 40 hours per week, for up to 30 years without adverse health effects. Then we have STEL, short-term exposure limits. That's the maximum concentration for a continuous 15-minute period. This is allowed for up to 4 times per day with at least 60 minutes between exposures. Then we have the threshold limit value, TLV, which is established by the American Conference of Governmental Industrial Hygienists. This list is updated annually, and the TLVs are listed as either an 8-hour time-weighted average or a 15-minute short-term exposure limit. It's important to know, though, that the TLV cannot be enforced. This is merely a recommendation. Going back to our first PowerPoint presentation, then we have some other terms such as LC50, that is the lethal concentration 50%. That means that at a given concentration of a pollutant or of a substance, 50% of a population would die. Usually we're referring to mice, which is the usual animal that's used in these kind of tests. But when it comes to the LC50, that's what you need to know. That's the concentration that is needed of a substance to kill 50% of a population. So that's a number that you definitely don't want to go near to. Then we have ppm, which stands for particles per million. You would also see every now and then ppb, which stands for particles per billion. That just merely tells you that for every million particles out there in the air, one of them relates to a given substance. This is a simple way of establishing a given concentration of a pollutant or a substance in the air. Another way to do so is in milligrams per cubic meter, as seen here. Then we have some other terms such as boiling point, that is at which temperature would a liquid turn into at which temperature would a substance will go from a liquid state of matter to a particle airborne gaseous state of matter. Then you have vapor density, that is whether a substance is heavier or lighter than air. That will give you information as to where to find a given gas. Usually substances that have a high vapor density would be near the ground since they're heavier than air. And the opposite is also true. Now let's talk about the respirators. When and why respirators should be used. Respirators are devices used to reduce workers' exposure to respiratory hazards such as fumes, mist, gases, vapors, and harmful dust. Respirators are also used to protect workers against oxygen-deficient atmospheres. An oxygen-deficient atmosphere is defined as having an oxygen content of less than 19.5%. You must first try to control air contaminants by eliminating the contaminants or substituting them with something that's less toxic, by implementing engineering control measures, such as, for instance, providing ventilation or ventilation by mechanical or natural means, and by potentially providing administrative controls, that is, reducing the amount of time that the employees are exposed to a given toxic substance. Now, appropriate respirators must be used when the controls listed above are not feasible, while the controls are being instituted, or when the controls are not sufficient to reduce the respiratory hazards to a level below the established exposure limits, or in an emergency, of course. Now, this nice flowchart establishes a path, a decision path that allows you to decide when is it necessary to use a respirator. Starting here from the top, are respirators necessary to protect the health of the employee, or are they required by the employer? Whether this is true or not, you just follow the path, and based on the decisions that you take, you might either find out that it's mandatory, that the need for a respirator is mandatory, or perhaps it's voluntary. And if so, they would fall under slightly different regulations. Now, the 5 steps to implement a respiratory protection program are as follows. Step 1. Eliminate the need for respiratory protection. The use of respirators involves liability. So if it's possible to eliminate the atmospheric hazard altogether, to avoid having employees use respirators in the first, then step 1 is the way to go. Step 2, invest the time to become knowledgeable about respirators. That is, based on the hazard that's present in a given facility, know what respirator needs to be used. Step 3, plan to seek the help of outside experts. Step 4, implement your written respiratory protection program. And step 5, establish a process to keep your program effective. That is, review it every year, perform internal audits, etc. Now, some elements of a respiratory protection program include respirator selection, medical evaluations, fit testing, use of respirators, maintenance and care of respirators, breathing air quality and use, training and information, and program evaluation. Now let's talk about the different types of respirators. First, we have the air purifying respirators. These involve several subtypes, such as filtering face piece respirators, which are often called dust masks. This will be the one shown in this image down here. We have the tight-fitting respirators, which have either a half mask or a full face piece, such as the one seen over here. And then we have the powered air purifying respirators, also abbreviated as PAPRs, which have a hood, a helmet, a tight-fitting face piece, or a loose-fitting face piece. These are usually battery-powered to supply purified air. Now, it's important to know that an air purifying respirator is useless in an oxygen-deficient atmosphere. As the name implies, air purifying respirators merely filter out pollutants or hazardous substances from the local atmosphere. However, they do not provide additional oxygen. So if you're working in a confined space that has an oxygen concentration that is lower than 19.5, these respirators will be useless and you might experience adverse health effects that pertain oxygen deficiency. When working in those kind of atmospheres, that is oxygen deficient atmospheres, you really want these kind of respirators. You want the atmosphere supplying respirators. You want supply air respirators, which provide breathing air through an airline from a source outside the contaminated work area. So, in this particular instance, you're getting air from the outside of, for instance, a confined space. Then you have the atmosphere supplying respirators, the SCUVAs, the self-containing breathing apparatuses, which allow the user to carry a pressurized, compressed breathing air cylinder. So as seen in the images here, you're carrying this cylinder on your back, which provides you with air. This allows you to circumvent any oxygen deficiencies in a given workspace. And lastly, you have atmosphere supplying more atmosphere supplying respirators, such as combination respirators, which are a mix between the SARS and the SCBAs. And you have escape-only respirators, which are intended for use only during an emergency exit. Those are small respirators that provide a limited amount of air that is merely assigned for use in an emergency to escape a hazardous condition. They are not allowed to be used for normal working conditions. They're only to be used in an emergency. Atmosphere supplying respirators are mostly used in high hazard atmospheres. High hazard atmospheres can be encountered during emergency situations, chemical spills, very high concentrations of contaminants, or the use of materials that have poor warning properties. Atmosphere supplying respirators must also be used in the following situations. When you have atmospheres for which there are no approved cartridges, for instance when you have methylene chloride, during certain welding operations that involve toxic metals that can produce fumes, during procedures that involve abrasive blasting, in oxygen deficient atmospheres, in conditions that are immediately dangerous to life and health when escaping from a hazardous environment, that's when you want to use these kind of respirators. Thank you, and if you have any questions, don't forget to check out the forums.